let's get started. My name is Matthew. I'm actually on the Android Studio platform team. That means I work on things like product stability, Kotlin integration. And one of the most exciting things I get to work on besides product stability is something called Android Lint. So that's what I'm here to talk about with you today. So Android Lint is actually a very powerful tool. I think a lot of you already know about it, but you might not know all the cool things that it can do. So despite the name, it's not just a linting tool. It's actually like a full-fledged stack analysis framework. And it's really powerful. You can write your own checks, and I'm going to talk about that today. This talk is really for anyone kind of really interested in programming languages, compilers, stack analysis. It's also for anyone who has had to deal with bugs in their project. So I think that covers the rest of you. Oh yeah, one last thing. I only have 20 minutes, but there's a lot of material, so I'm going to go kind of fast through some of these slides, try to keep up. The good news is that at the end of the day, you can go home, you can watch it on half speed on YouTube, and you should be able to understand some of it then. All right, let's get started. I'm going to go extra fast now, so let's keep up. All right, so what is Android Lint? Like I said, a lot of you probably already know. Even if you don't know the name, you actually do know what Android Lint is, because it's the thing that shows up warning messages in your IDE saying, hey, you're doing something wrong. And so in some cases, this is like telling you, hey, Gradle might be out of date. Do you want to update it? Or maybe you're not calling a super method in a method that expects you to do so. And right in Android Studio in the IDE, it'll say, hey, there's some code here, looks suspicious. Maybe you want to take a look. And sometimes it's warnings, sometimes it's errors that will actually fail the build. So some of you might not know, but there's actually a lot of different ways to use Android Lint. First one is on the fly, which is what I just mentioned, where it's kind of in the IDE. As you're typing, it shows error messages right away. You can also use something called inspect code. This is an action in Android Studio where you can run a batch analysis of your entire project. It's a really great way to kind of audit your project for common errors. And a related action called run inspection by name. So if you have a particular bug in mind, say you want to find a lot of thread annotation violations, you can run that inspection by name, kind of audit your entire projects in one batch analysis, and look through those one by one. Some of you might not know, actually, though, that you can also run lint at the command line with Gradle. So you do something like Gradle lint debug. That's one of the tasks that we have. And it's kind of the same thing. It'll just do a batch analysis for your entire project. And the really great thing about that is it'll make a HTML and XML report. So you can parse the XML report if you want to do something fancy with the results, or you can just take a look at the HTML report and go through your warnings. So even if you know what Android Lint is, I really want to do a deep dive into kind of the advanced use cases for Lint, because it's a very powerful tool. So first, I'm just going to talk about configuration. Kind of sounds boring, but it's actually really important for big projects. You want to make sure Android Lint is working for your project and for your needs. I'm also going to talk about annotations. It's a really powerful way to kind of mark up your code to help Lint help you even more. So kind of Lint automatically does as much as it can, but sometimes you need to tell it, hey, you need to give it hints to help you even more. Also going to talk about Lint internals. I'm really excited about this part because I really want to give you a good mental model for how Lint works under the hood. This will get you set up for kind of realizing how powerful of a tool it is, and also for writing your own custom Lint checks, which is actually the last step. And that's kind of the fun demo part. All right, so let's talk about configuration. The easiest way to kind of see what Lint is capable of is to go into Android Studio, open up Preferences, go to the Inspections window. You'll kind of find a heading that says Lint, and under there you can see all of the inspections that Lint has. There's actually hundreds, and most of them are enabled by default. But there's actually some that are not checked by default. And I encourage you to kind of just explore these, take a look at them, because some of these might actually apply to your project, even though we don't enable them by default. A really good example of this is something called Kotlin interoperability. This is just a set of checks that we created so that you can call Java code from Kotlin code and vice versa. And if you do things that makes that difficult, then Lint will actually warn you right in the IDE, like, hey, you might want to rename this function so that it's easier to call from the other language. There's actually another way to configure Lint, which is with Gradle. So if you go into your build.gradle file, you have this Android block, as you know. But you can also add a Lint options block. And there's some really powerful options here. So this first option, I'm just going to go through a few examples. This first option here is a really powerful tool. Anyone with a really big project, you really want to pay attention to this. So a Lint baseline is just kind of like, when you add this to your options, Lint will take a snapshot of all of the warnings and errors you currently have in your project. And what this will do is it'll give you a clean slate. So you'll say, like, hey, I want to take a baseline at this point of the project. and forget about all of the thousands of warnings that I already have. And then I only want to look at new warnings and errors coming in new code that my team checks in. And this kind of helps you get a handle on like the massive amount of code that you have and still be able to have clean code going forward. And then when you have more time, free time, you can go back and look at all the baseline issues that Lint has stashed away. Once you do that, so once you have a clean slate, either through a Lint's baseline or because you have a new project and you just want to say, hey, I want to have clean code forever, starting now, you can turn on warnings as errors. I really encourage you to try this out. It might not be for everyone, but if you care about clean code, definitely try to get this to work for you. And then, like in the last slide, you can enable specific checks that are not on by default, like interoperability. So some of you already have this Lint options block set up. And some more advanced things I want to talk about is performance issues. So one of the reasons we have this Lint options block in Gradle is because a lot of people run Lint on their continuous integration server. And so they're constantly checking their entire application for Lint warnings, Lint errors. Maybe they even block pre-submit if you have a new warning that someone just checked in. But some people are kind of concerned about performance. So just a few tips here real quick. Try to avoid the check all warnings option. I know it's really tempting. I just told you how to enable more checks. But actually, some of the checks are off by default for performance reasons, for example. So if you check all warnings, like you can say, oh, man, my time to check the project is just doubled. But be a little bit more selective in the checks that you turn on. Also try to avoid the Gradle Lint tasks. It's actually a parent task of multiple subtasks, one of which is like Lint debug or Lint release. The parent Lint task will actually run lints multiple times on a project for each build variant. And so that's just a really simple gotcha that you should try to avoid. Also, if you can, use the ignore test sources option. So by default, we already don't look at your test sources for warnings or errors. The theory being that you don't really care about how clean your tests are. But this option will actually make it so we don't even parse your test sources at all. And so presumably all of you have really, really well-tested code. So this option will help with that and make things go faster. All right, let's switch gears a bit. I want to talk about annotations. Annotations are a really powerful way to just give Lint hints for specific issues that you want to look for. So I'm just going to go for a few examples. A lot of you already know about the nullability annotations. Hopefully, you've used this a lot in Java. In Kotlin, you don't need them because it's kind of built into the language. But we also have really Android-specific annotations, which you should check out. So there's one called requires permission. You probably know about this one too, but it's just an example where we kind of annotate certain Android APIs with requires permission, maybe like the set wallpaper permission. And then Lint will actually kind of do some analysis on the code that calls into this API and say, hey, is the programmer actually checking that they have this permission? If they don't, then we can warn you, like, hey, it looks like you haven't checked that you have this permission. This might crash at runtime, and this impacts users quite a bit. There's also one of my favorites kind of annotations, which is UI thread and worker thread annotations. I think they're just called thread annotations in general. These are really important, actually. So a big problem with application development is a lot of UI frameworks require that you only update the UI on a single thread called the UI thread. And everything else has to be done on the background thread. So if you do a network request, you have to do it on a background thread. Because if you do it on the UI thread, the network request might block. You'll freeze the UI. User will be frustrated. You might not even see a crash report. And it's really hard to track down these issues. So we have these thread annotations where you can say, hey, this method should only be called on the UI thread or should only be called on a worker thread. And we have some analyses to track that down. So I'm actually going to do a demo of these analyses. Hopefully that's set up. So let's switch over. Can we switch over to the demo? Perfect. Awesome. So use your imagination a bit here. I'm going to go through an example. This is just Kotlin. Let's say we have a function. Oh, the screen is black. You're right. Awesome. Let's get started. So let's say we have a function called update UI. Obviously, we expect this to be run on the UI thread. So maybe this is updating the user interface, whatever you want. And then let's say we also have a function called network requests. So it's just a really contrived example. And this does some stuff. All right. And unfortunately, someone decided to call a network request from the update UI method. So this is a problem, right? As you can see, there's no errors or warnings. Starting issues like this are actually really hard to track down in general. But if you know about these thread annotations, you can add the UI thread here. You can add the worker thread annotation here. And instantly, Lint will say, hey, you're trying to make a network request on a UI thread. That can freeze the UI. You don't want to do that. So that's really, really powerful. I really encourage you to use these. Now, you might be thinking, hey, this is a really contrived example. This is too simple. Actually, what we have in our application is this UI method that calls a function foo, maybe. And then that function calls something called bar. And then that bar function calls the network request. There's just multiple layers of indirection here. And you're thinking, oh, Lint can't help us here, right? And as you can see, it can't right default, because for performance reasons, we don't try to do these advanced analyses. But actually, we do have an analysis for this. So I'm going to show you an example of that. You can do run inspection by name. The name of the inspection is called wrong thread, and then interprocedural. If you select that, select the scope. I'll just say module scope. And bam, it'll find the call path from foo to bar to network request. And I know you can't see this error message down here, so let me copy it for you. And I'll remove the class names. And so you can see the error message shows you, hey, you're starting update UI, you're going to foo, you're going to bar, and then you're going to network request. And that's annotated with worker thread. And that's an issue. All right, let's go back to the slides. So please check those out. That analysis is off by default for the main reason being performance. It's trying to do a whole program analysis. It's pretty expensive, so just use it when you can. Just try it out and see if it finds any bugs in your application. All right. So next time I talk about lint internals. This part's really cool. So the way lint works is it starts out by parsing your source files. So maybe you have some Java, Kotlin lying around, kind of builds the abstract syntax tree. And the first thing we do with that is we actually wrap it in something called UAST, which stands for Universal Abstract Syntax Tree. If you've dealt with these kind of things before, that might sound pretty familiar. But this step is really important because it means that when you write a check, you only have to write it once, and it works on both Java and Kotlin. And that's really convenient, actually. And then when you write a lint analysis, you're actually just operating directly on UAST. So when you write a lint check, you're just kind of scanning the UAST for your source code. You're looking for method calls that you're interested in. You're looking in expressions that you're interested in. And that's how it works. It's also important to point out, lint actually works also on all types of files. So you can look at Gradle files. You can look at XML files and resources. This is actually really powerful because it kind of gives us a holistic view of your entire application. And we can provide a lot more helpful warning messages with that. A couple more points here. So type information is available. You're not just looking at text. You actually have the whole AST with type information. You can do things like method resolution. You can do things like examining the class hierarchy of the class you're looking at. That's really important for preventing false positives and just having really powerful lint checks. That's kind of what makes lint so useful. We also have really tight integration with the IDE. So one of my favorite parts about lint is that it actually does show you the warning messages right in the IDE. I think that's critical because if you don't have that, then a lot of your warning messages would just be lost in some build output somewhere, and it wouldn't be useful to most people. So with that, we're going to move into writing custom lint checks. And what this means is that Android Lint is actually a framework. You can write your own lint checks. If you have something that annoys you, like either a common bug that you run into on your team or just something that you want your colleagues to watch out for, you can write your own lint check. You can upload it to your code base, and all your colleagues will see it in the IDE, things highlighted. Quick note here, lint actually has an unstable API. All this means is that we don't promise that we keep it the same from release to release. The good news is that it's not changing too often, but no promises. The other good news is that unstable APIs are really fun to play with. So, all right, and with that, we're going to move into the demo. So let's switch over. Awesome. Much faster this time. All right. So don't bother reading code too much. The example I want to set up here is that you see that your colleagues are maybe calling thread.yields pretty often. And if you look at the documentation for thread.yield, it's actually not a very useful method. I mean, if you're writing very advanced concurrent data structures, maybe it's useful. But in other cases, you really want to avoid it. It usually doesn't do what you think it does. So let's say we want to write our own lint check that actually catches calls to thread.yields and warns people that they're doing that. So right now, it's not highlighted. There's no lint checks yet. I want to show you how I have this set up. So you already have some kind of Android application module here. Here it's just called app. The way you're going to write your own lint checks is all you're going to do is you're going to make a Java module, maybe called checks, for example. And you're going to add a dependency from your Android application to the checks module. And we have this nice lint checks block here, which will make it really easy to do that. Once you have that set up, and I know I'm skipping over some of the details here, but I'm going to have some links at the end that you can look at sample projects. So once you have that set up, we can actually go right to the lint check itself. So here I have a class called yield detector. As you can imagine, this is a detector for calls to thread.yields. It extends some classes in the lint framework. And I already have typed up some of the metadata for this check that we want to have. So there's a name, there's a brief description, and there's an explanation for how to fix the issue. Maybe there's a severity, whether it breaks the build, et cetera. So once we have that metadata, I'm actually going to start typing some code here. So one method to be aware of is called getApplicable method names. So the way lint works is, there's a couple options. You can either make your own AST scanner, which kind of just give you total control. You can scan the entire source file, look at it for whatever you want. But for performance reasons, we have these hooks where you can register with lint, like, hey, I'm only interested in method calls that have this particular name. And so here, we're actually only interested in method calls with name yield. And if I have any typos, it's not going to work. So let me know. Once you have that hook in place, we have to write the hook itself. So here we can say visit method. And I'm going to make sure that's readable for all of you. So this method should really only be called when we come across a yields function call in the source code. So we can say, OK, let's assert that the method name we're looking at is actually yield. So this should always be the case. And then because we have type information, we can do due diligence and make sure that we don't have a false positive here. Because maybe there's another class with the function called yields, and we want to make sure that it's actually the Java lang thread.yield. So here we're going to check. We have some helper methods. I'll type it out. If you look at the evaluator, you can say is member in class. We're going to pass it the resolved method node, and then we're going to give it the class name. So java.lang.thread. This just means, if this method that they're calling is actually part of this exact class, then we can report the error. And then I'll say context.report. I'll give it the issue that holds the metadata we have above. I'll give it the node. I'll give it the location. So we're telling lints hey, here's where the error is. This is what you should highlight. And I think I have to give it a message. So let's say, please don't use this. Obviously, you should use a more helpful error message. All right. That's all it takes. If I have no typos, I'm going to make the project. Looks like it's done. And if I go back to our application, bam, Lint has already scanned your source code. It's already picked up your lint check right in the ID. It says, please don't use this. And that's really powerful. You can make this pop up for your colleagues and everything. So awesome. Let's go back to the slides. All right, 50 seconds left. I'm pretty happy with the timing here. Here's some links. I really want you to check these out. So if you've never read the Lint overview on our developer page, please go there. It's got a lot of information, both from this talk and a little bit more. Please check out the annotations page. I just touched on like 3 random examples, but there's so many useful annotations that can really prevent a lot of bugs ahead of time before your users ever see them. If you are really excited about this demo I just gave at the end here, check out the sample project we have on GitHub, where you can actually write your own custom lint checks, and it'll kind of get you up to speed. And finally, if you run into any issues, we have a Lint mailing list where you can go to for help. Many of you might know Tor. He's pretty active on the mailing list, and I'm pretty active on the mailing list too, where we kind of answer all the questions that get asked there. All right, and with that, thank you so much. If you have any questions, don't ask them now, but I'll be out in the sandbox area afterward, and I'll be happy to answer any questions. So please check out custom lint checks. Thanks.